Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about exponential distribution concept. The exponential the exponential distribution is one of the widely used continuous distributions. It is often used to model the time elapsed between events. The exponential probability density function finds applications the exponential probability density finds application in reliability theory, queuing theory, and random process. In these applications, the exponential density function corresponds to the lifetime of an equipment or service time of the counter in queuing theory or demands for computer center and successive arrivals in telephone booths, etc. So these are some important applications of the exponential density function. A continuous random variable X having the range 0 to infinity is said to have an exponential distribution if it if it uh, if it has a probability density function is given by capital Fx of x is equal to lambda e power minus lambda x for lambda greater than 0 and x greater than or equal to 0 and f and density function is equal to 0 otherwise. In this probability density expression, substitute different values of x. And what are the different values of x? X greater than or equal to 0. X greater than or equal to 0 means x is equal to 0 to infinity. And lambda is constant. Lambda greater than 0. Substitute different values of the lambda. So that our lambda is equal to 1, 2, 3 like that. So for different values of the lambda, so the graphical representation of the exponential density function graphical representation this one. So this is the probability density of exponential distribution for various values of lambda. Next, find out the corresponding cumulative distribution function. So we know that from the definition of the cumulative distribution function, capital Fx of x is equal to probability of x less than or equal to x, which is equal to integral minus infinity to x density function into dx. So now here in this equation, this is the definition of the probability distribution function or the cumulative distribution function definition. On RHS side, the x is varies from minus infinity to x. When you applying the definition of the exponential density function here, so from the definition of the exponential probability density function, fx of x is equal lambda e power minus lambda x for x greater than or equal to 0. So x start from 0. So when you are applying the exponential density function, the range of x is start from 0 and final value is as it is same, that is x. So therefore the distribution function, cumulative distribution function fx of x is equal to integral density function. What is exponential density function? Lambda e power minus lambda x for x is equal to x is start from 0 and the final value is as it is same, that is x, integral 0 to x lambda e power minus lambda x dx. Lambda is the constant that is written before integration. Integral e power minus lambda x integration is e power minus lambda x by minus lambda over 0 to x. Now applying upper value and lower value of x. Now here lambda is the cancel. Minus of substitute upper value of x e power minus lambda x minus substitute lower value of x e power minus lambda into 0. Lambda into 0, 0 e power minus 0. E power minus 0 value is 1. So multiplying minus within the bracket term, we get cumulative distribution function fx of x is equal 1 minus e power minus lambda x. So in this equation, substitute different values of lambda. So that is lambda greater than 0 and substitute x greater than or equal to 0. We get the graphical representation of the cumulative distribution function shown in this figure. This is the concept of exponential distribution.